Okay, well, welcome back everyone. I'm just going to go over some of the key concepts of this next section. A lot of it is just definition. So this is page 144 out of the handouts. You may want to just print that for the sake of having the terms in front of you instead of kind of flipping back and forth as you're going through the questions. The first part, again, just basically definitions, understanding what these terms mean, so that not so you can define them for me, but so that when you see the word in a problem of some sort, you'll actually know what it's asking about. So really quickly, chord is a line segment that joins two of the edges of the circle. Diameter is a chord that passes through the middle. Now I shouldn't have probably used that term segment up there, because segment in circle is, of course, this little area in here is what it's showing. It's sort of the shaded area. The arc is the distance around the edge of the circle between the two key points. A tangent is a line that touches something in one spot, in this case touches the circle in one spot, and a secant cuts it in two pieces, or two locations, sorry. Sector is by definition basically a piece of pizza. So it's a part of the circle that's been sort of isolated by looking at the center of the circle. So in this case, there's two radii touching, and the angle in between is called the central angle. Last definition is an inscribed angle, and that's if you have two chords on a circle, the angle between them. Okay, so basically just as the angle in the circle is for, okay. So yeah, and that has to be actually on the edge of the circle, but I guess that's what I said with by chords. Now the part of this that we need to take a look at, and I'll tell you, I've done the video once already and it didn't quite work out, so the solutions are shown, so I'm just going to cover, I've already written them up, so I'm just going to cover them in a second here. When I look at the definitions here, or the explanations here, and I don't like when they give me a formula to follow unless it's necessary. I'll tell you right off, this third one, I guess, is necessary. But the other two, to me, it looks like there are three formulas here to memorize, and really there aren't. So we're just going to go and do a couple of quick questions here. If I'd given you this question, now it's a little messy because of the number of things on the screen all at once. But if the question were, find me the area of this half circle, nobody would hesitate. You know that area is this, or if I asked you to find the distance around the edge, sort of from here around to here, again, nobody should hesitate. The area of a full circle is pi r squared, so essentially we have half of that now. Divide that by 2 or multiply this by 1/2. Same idea, circumference of the entire all the way around is 2 pi r or pi d. In this case, we only go halfway, so we can divide that by 2. The same would be true if we continued over here. Let's move this out of the way. If I was asking you to deal with this area in here, and we see that it's a 90 degrees, so we know that that is 1/4 of a circle. And that's, of course, same sort of idea once more if I was coming around here. So what I've got written here is in blue, to try to calculate the blue, area is 1/2 of the area of a full circle, so 1/2 pi r squared. We recognize that 26 is the diameter, so 13 is the radius, and I didn't even bother to solve it because it should be second nature. Same idea with circumference, 1/2 of pi d or 1/2 of 2 pi r. Either one of those works. And then if I simplify that, it ends up being basically the same as pi times r, so 13 times pi. Again, punch into a calculator, get your answer. The only difference now, if I were dealing with the quarter instead, I would have a quarter in here, a quarter here, and of course over here as well. Recognizing, I guess, that either this or this would be used, you don't have to do both. And then, of course, the rest of it would be done the same way. So that leads us to today's work. The little formulas that started that section. So these two, length of an arc, an area of a sector, those are basically the same two things we just did, except we're talking about not necessarily exactly half or exactly 1/4 or exactly 1/3 of a circle. So essentially all we're asked to do is find a fraction of the circle, just kind of in general. And to do that, we'll simply take whatever the number of degrees we're dealing with is and divide it by 360. So the area of this sector, sorry, got myself hung up there for a second. This sector here is going to be 150 360ths of the circle, or 150 degrees divided by 360. 360 is a whole. I have 150 out of those 360. That means I have that fraction of the area. Same idea with if I'm trying to find the distance around the arc here. I have 150 out of 360 of the circle. 60ths, sorry, of the distance around the circle. So basically, just that's what those two formulas are trying to tell you. Just take a fraction of the whole. Have that percentage, or that fraction out of 360, that number of degrees out of 360. It's a fraction of the original, and otherwise we can just solve it. The last one, this is an example just out of that page. Essentially what we've got here is a little bit of a tricky formula. I've never really used it this way before, but for our purposes it'll be fine. Essentially, and I won't go over it in too much detail, we're looking to find the area of this little segment in here. And so the formula essentially takes the area of the whole sector and subtracts the area of the triangle that's not part of the shaded area. And again, it's kind of hard to see here. This is a modified version of the area of the sector, and then this with this together, and again some simplification has gone on here, takes away the area of the rectangle itself. You don't need to really understand that too much, other than to know that that's what it's doing, is it's calculating the whole sector and then taking away the unwanted triangle. For our purposes, we'll just use this. I'll be honest, I don't think there's much chance of that showing up on the exam, but just sort of in the next section, there may be a question or two that we kind of need that to do some of the further work, so I don't want to discount it entirely. So I'm going to stop there. Like I said, print off page 144 for the definitions, and then I'll assign some questions where more or less the work shouldn't be too difficult. A lot of it will probably be dealing with the areas and the arc lengths and so on.